Hello everyone, I am Ashok from AKB Tutorials. So in this channel we are discussing various topics related to mechanical engineering, and we are continuing with Mohr circle, that is related to strength of material. So today we will see the last part of Mohr circle. Okay, let us start the Mohr circle. So we have seen how to construct Mohr circle and how to find the various elements, whatever we can come to know from this Mohr circle. Today we will see analytically. Now this is the stress condition or stressed body, in which it is seen that along x-axis sigma x stress is acting, along y-axis sigma y stress is acting, as well as tau xy shear stress acting on x face in anti-clockwise direction, and on y face it is in clockwise direction. This is the most complex stress system, and the inclined plane which makes an angle theta with positive x direction. Okay. Now on this, what should be the condition of sigma n and tau? So we have seen all these things. Now let us see this is the condition of stress acting on the body, and how to get sigma 1, sigma 2, that is major principal stress, minor principal stress, then tau max from this diagram analytically, as well as the normal stress with maximum shear stress, and at last we will see the sigma n and tau at any angular orientation. Okay. So with the information whatever is available in the stressed body, that is on x face sigma x and tau xy stress is acting, both are positive. Sigma x tensile positive and tau xy it is in anti-clockwise sense, on x face it is positive. So this is the axis we have drawn, that is sigma axis, tau axis, and this is the origin, and from origin measure the distance, that is sigma x, from here to here it is sigma x, and this is tau xy. So this first point is marked, so we have seen in construction part, that is sigma x, tau xy. Now go to y face, so sigma y is positive and tau xy is negative. So from origin we have measured the distance sigma y and tau xy. So we have got these 2 points. Point number 2, that is sigma y, tau xy. Now join these 2 points, so it will intersect at sigma axis at this point. So point 1 and 2 if we join, so it will intersect at point C, and the C will be the center of Mohr circle. By taking this one as center and this one as radius, or this one as radius, C21 or C22 as radius, draw the Mohr circle. So we have drawn the Mohr circle. Now from the circle it is seen this point and this point. The circle where it is intersecting the sigma axis, so tau value will be 0. That means this point and this point indicates the principal plane. Okay, and the stress, normal stress corresponding to this point are known as principal stresses. So as this one is greater one, so it is called major principal stress, and this one is smaller one, so it is minor principal stress. So we have got major principal stress and minor principal stress, sigma 1, sigma 2. And also we have discussed that from here to here, so the point which is just above the center of Mohr circle or below the center of Mohr circle indicates the maximum shear stress which can occur under this condition of loading. So that means this value will be tau max, and the normal stress which will occur along with this tau max, so this value will be the maximum normal stress which will occur with maximum shear stress plane. So this will be this value, so we will measure this value. Now we are going to calculate sigma 1, that is the major principal stress. What is major principal stress? This value will give the major principal stress. So this value will be equal to OC, say this point is E, so we can write is equal to OC plus OE, CE, OC plus CE, that will give sigma 1 value. Now what is OC value? Now OC value is sigma y, up to this it is sigma y and this value. So up to this it is sigma x and up to this it is sigma y. So if we give the name E, F, G, H. So sigma 1 is given by OC plus CE. Okay, now if we find GH, what is GH value? GH will be equal to sigma x minus sigma y, right? GH. So from here to here, this value from origin to this value is sigma x and from origin to this value is sigma y. So this value from G to H, it will be, now what is CH value? CH value, so it is given by, CH value is given by sigma x minus sigma y divided by 2, right? So in this right angle triangle, this value is given by CH, so we have got sigma x minus sigma y by 2, and this value is tau xy. Okay, so we can find C1 distance, C1, C to 1, that distance will be root over of sigma x minus sigma y by 2 whole square plus tau square xy. Okay, so that is C1, that is the radius of Mohr circle. Now we have got O to C value. O to C value, that will be equal to sigma y plus GC value. GC and CH is same, so we can write sigma y plus sigma x minus sigma y by 2. So that will be equal to sigma x plus sigma y by 2. So OC value, what is OC? OC is the normal stress which exists with the normal stress with maximum shear stress, or normal stress with maximum shear stress plane, that is given by sigma x plus sigma y by sigma x, sigma x plus sigma y by 2. So that is the maximum normal stress which will occur in the maximum shear stress plane, and tau max is given by O21 or radius of Mohr circle. So tau max we can give by root over of, so if we take out half here, so we can write half square root of sigma x minus sigma y whole square plus 4 tau square xy. So this is the maximum shear stress occur in this stress system, and this is the normal stress which will occur along with this shear stress plane. So we have got these two. Now we will see sigma 1 and sigma 2 value. Now if we see sigma 1 value, sigma 1, this is the sigma 1 is equal to OC plus CE. OC plus CE. What is OC value? OC value we have calculated, that is sigma x plus sigma y by 2, sigma x plus sigma y by 2 plus root over of half, root over of, so this much, because this is the radius of Mohr circle. So this one is sigma x plus sigma y by 2, and this one is radius of Mohr circle, that is half root over of sigma x minus sigma y whole square plus 4 tau square xy. So this is the sigma 1 value, and sigma 2 value this one. So this one, so we will calculate sigma 2 value. So if we calculate sigma 2 will be equal to sigma 2, which is equal to OC minus CF. So from figure, OC minus CF, that will be sigma 2 value. So what is OC value? This is the stress, normal stress, which will occur along with the maximum shear stress plane. So we can write sigma x plus sigma y by 2 minus CF. What is CF? CF is the radius of Mohr circle, that is root over half root over of sigma x minus sigma y whole square plus 4 tau square xy. So this is the analysis of Mohr circle. So any Mohr circle, geometrically you can just analyze the Mohr circle by this way. Now we will see some other topics, that is some problems related to this Mohr circle, by varying how we can draw the Mohr circle. So various cases we will take, 3-4 cases we will see how to draw the Mohr circle. So we have seen so many cases. Again we will just refresh the idea by taking sigma positive or sigma negative as well as tau positive and negative. Let the case 1, so we have to draw the Mohr circle. We have to draw the Mohr circle. The stress condition is, say, this is the stressed object at angular position theta. If the body is under sigma x stress, that is negative, sigma x is negative, and tau is sigma y is positive, sigma x is negative, sigma y is positive, and the angle made by inclined plane is in clockwise sense with x direction. In theta angle it is inclined with x direction in clockwise sense. Now for this condition we have to draw the Mohr circle. So we know how to draw the Mohr circle. For this, draw the axis. that is origin, sigma axis and tau axis. Now go to x phase. X phase only sigma s negative stress is acting, so we are considering this value is say 40 megapascal and this is 30 megapascal. Okay, so for time being we are considering this. Now sigma x is minus 40, so by using some scale from origin measure a distance of 10, 20, 30, 40. So this point indicates the point 1, which is 40, 0. 0 means shear stress is 0. So 40, 0. This is the point 1. Now go to y phase. Y phase is sigma y is positive and 30. So positive, we are moving towards right, 10, 20, 30. Okay. So this is the point 2, that is sigma 2, 0. So we have got sigma 2 means 30, 0. Okay, 30, 0. So we have got second point. Now divide this. So somewhere here you will get the, so divide the distance between point 1 and 2, point 1 and 2 into 2 divisions. So you will get the center of Mohr circle here. Now take this one as center and this one as radius, or this one as radius, complete the circle. So if you draw the Mohr circle, you will get this circle. Now we have drawn the Mohr circle. Now next step we have to find the x direction. So x point is plotted here, this point is plotted here, so this direction also denotes the x direction. Now we have to rotate x direction, means from here, center to this is the x direction. So this direction we have to rotate in the same sense. Here it is in clockwise sense by theta in the actual body. So here we will rotate this by 2 theta angle. So if we rotate this in 2 theta angle, say we are rotating this, it is 2 theta angle. So we will get new x direction, new x direction. So we have got new x direction. Now this is the new x direction. Extend this so that it will touch the other side of the circle. So this is called the foot of new x direction and it is marked by point P. And from this point drop the perpendicular to sigma axis and this point is marked as Q. Now this point is C, center of Mohr circle, this point is the origin and this point is the Q. So origin is marked as O point, so measure distance OQ, it will give sigma n value, measure distance PQ, it will give you tau value on the inclined plane, and from origin you just join this point P. So this will give you sigma r value, that is OP, measure distance OP, it will give you sigma r value, and measure this angle, that is POQ angle. So that angle is denoted by phi, is known as angle of obliquity. Okay, by this way we can solve this problem very easily. Now we will see the another problem. So that is second problem. Say this is the stressed body. The body is under pure shear stress. Say the clockwise shear stress on x face and anti-clockwise shear stress on y face it is acting. So tau xy, tau xy, tau xy, tau xy. Okay, now we are considering, say, this is the inclined plane makes an angle theta with positive x direction. Now what should be the stress condition on the inclined plane? That is sigma n and tau. So we will calculate by using Mohr circle. So for this, draw the Mohr circle. So for this, first you draw the axis. This is the origin, sigma axis, then this is the tau axis. Okay, now go to x phase. What is the stress condition? Sigma x is 0 and sigma y is equal to negative, tau xy negative. So we are considering tau xy is equal to 20 megapascal. Okay, or 200 megapascal, sorry. Tau xy is equal to 200 megapascal. So this one also 200, this one also 200 megapascal. Now on x phase, what is the stress acting? So on x phase, sigma value is 0 and tau value is minus 200. So if we plot this 0, say by some scale it is minus 200. So this is the first point we have plotted, that is 0 minus 200. So we are writing just 200. The first point we have got. Go to y phase. Y phase means this is the stress condition, that is sigma y value is 0 and tau value is plus 200. So sigma value is 0, tau value is plus 200. So this distance and this distance will be equal because 200. So 0, 200. So we have just marked these 2 points. So we have got point 1 and point 2. Now we can easily draw the Mohr circle by taking this one as center, because divide this into 2 parts, that is this will be also the center of Mohr circle. Now complete the circle. So if we complete the circle, this will be the Mohr circle. So we have got the Mohr circle. Right? Now we have to rotate x direction. Where is the x direction? So this direction will be the x direction because x point is plotted here. So this direction is x direction. Now from x direction, if we move in anti-clockwise sense by theta angle, so we will get the inclined plane. So here also in same direction we will move by 2 theta angle. Say this is the 2 theta angle. So 2 theta angle, if we move from here to this direction, so this will be your new x direction. New x direction. Now extend this line to the other end of the circle so that it will touch the circle. So this is called the foot of new x direction marked by point P. And from this point, just drop the perpendicular on sigma axis. So this point will be your Q point. So now OQ denotes by measurement. OQ will give you sigma n value on inclined plane, that is this value will be given by this, and measure PQ, it will give tau value, that is this shear stress. So this value is shear stress value, and join OP. So sigma r also will be equal to sigma r is equal to this is also equal to OP. Okay, it is already joined, so no need to join. And this angle will be phi. That is POQ angle is known as angle of obliquity. So this is the solution of this problem. Now we will see another problem, that is the problem number 3. Okay, all the problems are similar problem. So this is the stressed body. Just you check the body. What are the stresses acting on the body? First you find out that. Say sigma x, it is acting in, sigma x is a compressive stress, and also sigma y compressive stress. And let the inclined plane makes an angle theta with negative x direction. Theta with negative x direction. Now what should be the condition of sigma n and tau value on inclined plane? So that we are going to calculate by using Mohr circle. So for this, draw the Mohr circle. So this is the axis. Say this is your origin, sigma axis, and this is your tau axis. Now go to x phase. What is the stress acting on this? Sigma x. Say we are giving this 60 megapascal and they say this is 40 megapascal. Now on x phase, what is the stress acting? Only sigma x, tau is 0. So 60 megapascal by some scale. So say this is 60 megapascal, 60 0. So this point is 0.1, 60 0. This is the first point which is obtained from x phase. Now go to y phase. On y phase, sigma y stress is acting in negative direction, that is negative stress, that is compressive stress. Sigma y is compressive 40. So by using the same scale, if this one is 60, so let this one is 40. So we marked this point 2, that is 40 0. So these 2 points we have got. Divide this distance and draw the Mohr circle. So this will be your Mohr circle. So Mohr circle is drawn. Here is the x direction. So point 1 is plotted here. So x direction will be in this direction. This is also x direction. So we have marked x direction. Now we have to rotate x direction in clockwise sense by 2 theta angle. So rotate from here by 2 theta angle. So this angle is 2 theta. So this becomes new x direction. That is new x direction. Extend the line new x direction so that it will touch on the other side of the circle. So this point mark as P point, and from P drop a perpendicular on sigma axis. That point is Q. Now you can measure easily Q. This point is P. So OQ distance will give you the sigma n value on the inclined plane. Now you can see sigma n value is towards left, means it is negative. So OQ will give you sigma n, it is towards left, so it is negative. Negative means it will be compressive. So instead of sigma n is acting like this, so it will act like this, sigma n. Now you can find tau value by measuring the distance PQ is equal to tau. So you can see this is also negative. That means it will be n clockwise sense. So it is in clockwise sense. Okay, tau. And join O to P point. So this OP will give you sigma r value, or it is simply root over of sigma n square plus tau square. And measure this angle. That angle we are marking by phi, that is POQ angle. That angle is equal to phi, that is angle of obliquity. And we will see the last complicated case, and I hope your idea regarding this Mohr circle is clear by my lecture. Now take the last case, that is, let this is the stressed body. The body is under sigma x is negative stress, that is compressive stress. Sigma y is tensile, that is positive. Also, along with this, on x phase, the shear stress acting in anti-clockwise sense, that is tau xy. So on y phase it will be clockwise sense. So we can mark here tau xy. And the position of inclined plane, let inclined plane makes an angle theta in clockwise sense from x axis. So this is the theta with negative x direction. Now we have to find out what is sigma n and tau value developed on inclined plane by using Mohr circle. For this, draw the axis first. First you draw the axis, that is sigma axis and tau axis. So we have drawn sigma axis and tau axis, and just put simply some value, that is say 80 megapascal, and sigma y it is 60 megapascal, and tau xy is equal to 40 megapascal. So now go to x phase, check the stresses acting on x phase, that is 80 negative, 40 positive. So 80 negative, say this is 80, this denotes 80, this is the origin, from origin measure the distance 80, and 40 is positive, so let this one is 40. So 80, 40, so point 1 we have marked, that is 80, 40. Now go to x phase, check the condition, that is sigma y positive and tau is negative. Sigma y is 60 and tau is 40. So by using same scale, says this one 60 and let this one is 40. So we have got second point, that is 60, 40. Now join this point 1 and point 2 by a straight line. So somewhere it will intersect on sigma axis, right? So it will be somewhere here. Okay, anyhow. Now take this one as center and this one as radius, or this one as radius, draw the circle. So this becomes the Mohr circle. Now you find where is the x direction. So here x point is, x phase point is plotted at this point. So this will be your x direction. Now rotate x direction by 2 theta angle in clockwise sense. So from here you measure this rotation. So here say this becomes 2 theta angle. Okay, so this is 2 theta. So extend this line so that it will come somewhere here. Okay, so just clearly show it so that it will be easy. Just you take some inclination, so it will be easy. Okay, so this angle, say it is 2 theta from here to here, 2 theta. So this will be your new x direction, new x direction. Now extend this line so that it will touch the circle, and this point is the foot of new x direction. From this foot you drop the perpendicular. So let this point becomes Q. So we have got point P, point Q, and this is the origin. So from origin you measure the distance OQ, and that will give you sigma n value. Measure distance PQ, it will give tau value on the inclined plane. Then join O to P. Okay, so OP will give you sigma R value, that is the resultant stress acting on that inclined plane, and measure this angle, that is POQ angle. Say this angle is phi, this is the angle of obliquity. Okay, this is all about the Mohr circle. Now one important point is, for finding the result correctly, you have to use the scale. So the concept of drawing to be used here. So we require set squares. So we have to use set squares, then pencil compass, okay, and the scale ratio. So if it is not coming within that A4 size sheet or the graph sheet, we have to use the scale factor, that is reduced scale or a large scale. So that concept you have to use here. Okay, and the result which is obtained by analytical method may not exactly match, it may vary 5%, so it is acceptable. So to get the accuracy of this result, your pencil should be sharp. Pencil should be sharp, and you have to follow the scale factor, and then pencil compass and set square. So you have to use this, as well as scale also is required for measuring the distance. So that means whatever the stress condition is given, so that stress condition, by using this condition we will draw the Mohr circle, follow the various steps, and ultimately by measuring the distance we will give the answer. So this is all about Mohr circle. So friends, I hope the Mohr circle, concept of Mohr circle is clear to you all. Okay, if any doubt, please just put the comments in the appropriate section, so I will come to you again. Okay, that's all for today. If you like the video, please like, share and subscribe the channel, and we will meet you soon with next topic, that is shear force and bending moment diagrams. Okay, that's all for today.